Hi, this is Colin Goebel. In this video, we'll extend the bouncy ball demo. We're at step 3 now, and we'll extend it to add a paddle which the user is going to control with the left and right arrows on the keyboard. To show you what I mean, I'll start step 3, and we'll try and bounce these balls with the paddle. It's a little bit tricky. I don't think I'm going to do terribly well here. And you get the general idea. We've got a little bit of a game going. Oops, one went underneath there. And we're bouncing the balls off of the paddle. Obviously, we don't quite have a game of breakout yet, although it is a pretty fun game the way it is. Okay, let's take a look at the code that was necessary in order to get that to work. As before, we haven't changed the ball structure. Each ball still has a unique ID, an X coordinate, a Y coordinate, a component of velocity in the X direction, and a component of velocity in the Y direction. We still have 5 balls. Windows are the same size. The background is the same color. We do, however, have 2 images. We have a ball image and this time a paddle image. The ball we're going to number 1. That's how DarkGDK identifies it. And the paddle we're going to number 2. That's how DarkGDK identifies the paddle. So the sprite associated with the paddle we're going to number as 2. We're going to have lots of ball sprites, and we're going to start numbering them from 100. Okay, in DarkGDK, nothing changed here. Same display mode, sync on, 60 frames a second. The escape key programmed as in steps 1 and 2. Randomize the timer so that the balls start up in a different direction. When we load the ball, the transparent color is black as before. Slight difference here though, for the paddle image I used, it turns out that the transparent color has a red component of 66, a green component of 65, and a blue component of 0. So those are the color numbers for the transparent color for the paddle image. As you saw, we still have an array of 5 bouncing balls. We initialize them in each case exactly the same as we did in the previous step, except that in order to make the game a little easier to play, we want the balls when we start the game to move in the upward direction so they're not all moving directly towards the paddle, which makes it very hard to play at the beginning. So I've changed the parameters for the direction a little bit. We've set the initial direction to 65, to 45, plus some random number between 0 and 90. So we have an initial direction of any number somewhere between 45 and 135 degrees. That should cause the balls to start moving upwards when we start playing the game. Okay, as before, we give each ball a unique ID because they all move around independently, and we, as before, paint our 5 balls on the screen. Now, in this case, we have a paddle. The paddle moves in the horizontal direction. So at any point in time, I've named the X coordinate of the paddle X paddle and given it an initial value of 200. The Y coordinate of the paddle, which is the distance from the top of the screen, I've set to 300. So Y paddle is equal to 300. As we play the game, we'll see the value of X paddle will change as the player moves the paddle from left to right, but the value of Y paddle doesn't change because the paddle doesn't move up and down. Okay, so we have a sprite on the screen. The paddle sprite we now need to render on the screen. The image we defined earlier that we're going to use the image number for the BMP IMG paddle. We're going to paint it on the screen in the position X paddle and Y paddle. And the sprite number SPR paddle we'd initially set to 2. That's just, as I said, a unique number that identifies that particular BMP that we're using for the paddle sprite. Okay, here's the main loop again, 60 times a second. I don't think anything really changed very much with the movement of the ball. at least initially. So we set the background to gray. We move the balls around the screen according to the velocity vector. If the balls hit the left, right, top, or bottom of the screen, we reverse the component of velocity. And here's the code that moves the paddle. So if the user holds down the right arrow key, the function to tell us if the right arrow key is depressed is db right key. If that function returns a value of true, then the right arrow key is depressed in that game step, and we increase the value, the x coordinate of paddle by 4. That will cause the paddle to move to the right. If the user has the left key depressed, then we will subtract 4 from the x coordinate, which will move the paddle to the left. So those functions, db right key and db left key, are functions that are provided by darkgdk. And other than knowing what they are and how to use them, we don't have to worry about them anymore. Okay, the next thing that we need to do is to see if the sprite, if any of the balls have collided with the sprite. So we need to look at each ball in turn. So here's the usual loop for all 5 balls. I equals 0, I less than the number of balls, I plus plus. For each ball in turn, we need to know if it's collided with the paddle. And the function that does that is db Sprite Collision. This returns true if 2 sprites overlap. And we take 2 parameters, and they're very simple. They're the ID of each of the 2 sprites. So the first parameter here is the ID, the sprite number of the ith ball, ball square brackets I, the ith ball in the array of balls. We take the sprite ID of that ball, and we see if there's a collision with the paddle sprite, SPR underbar paddle. If there is, there's a couple of things we have to do. We have to reverse the direction of the balls. If the ball's going from top to bottom, it has to bounce off the paddle, and we do that with this line here. Have to reverse the direction. But we also have to move the ball away from the paddle. Otherwise, if the ball collides with the paddle, it will continue. If we reverse the direction, if you take that line out, you'll see what happens. The ball gets stuck on the paddle. The 2 things kind of get glued together, and it's an extremely obvious and unacceptable bug. So this line of code is a slightly subtle line of code that has the effect of moving the ball away from the paddle so that the ball doesn't get continually stuck against the paddle. Try commenting that line out and you'll probably see what I mean. Okay, so the next thing we need to do, we've just got to render the paddle and render the balls. Render the paddle is easy. We call db sprite, paddle image, x coordinate, y coordinate, and SPR paddle is the paddle sprite ID. We render all the balls again as we've done before, no change to that code, and we're done. The only thing that changed at the bottom here is when we clean up our resources, we've also got to remember to clean up the paddle sprite. So once again, here's what it looks like. And oh, there's a ball there. It's kind of got stuck, and that happens if you hit the balls right on the edge of the paddle. And so there's a few little problems here that are subtle to get rid of. Won't worry about them right now, and we'll just work on our game. Thank you.